Another limit problem today. Just like with any limit, we're really got to focus on what x is approaching. And in this case, x is approaching 4 from the left, which means that we have to unpack this thing. And I'm going to use a method called investigation. And it's a numerical method. So in this method, I'm really looking at specifically what x is approaching, and we have values like 3.9. As it gets closer to 4 from the left, we would be looking at 3.99. Closer still would be like 3.999, and you get the progression. And as x gets close to 4, x squared is getting closer and closer to 16. But all of them are going to be less than 16. Which means that 16 minus x squared is going to get closer and closer to 0. But if you take something 16 minus something that gets close to 16 but isn't quite 16, all of these values are going to be positive. The reason that's important is that since 16 minus x squared is approaching 0, but from the positive side, the square root of that will also approach 0. If we had approached 4 from the right, we would have gotten values that were greater than 16 for x squared, and the square root that we'd be taking would be negative, and that limit would fail to exist. We also have the option here of looking at this graphically. And this is a type of graph that I think you'd be good to recognize, that y equals the square root of 16 minus x squared is really just a semicircle with a radius of 4. And if we take a look at that, you can now see as we approach 4 from the left, from this direction here, you can see the function value getting closer and closer to 0 with a hard stop there and a hard stop there. So you could also approach this graphically as well.